Live from New York, it's Ask an Engineer.
Hello, everybody. Welcome to another fabulous Ask an Engineer. We're broadcasting live here from the Adafruit factory, where we have a lot of bubble wrap downtown Manhattan. I'm Lady Ada. I'm the engineer. With me is Phil on camera control. Just us two today.
And the Adafruit factory is a member of this cast.
That's true.
Yeah, there's
the city's a character.
Yeah, the city's a character. Adafruit factory is a character. We have shipping, we have receiving, we have the photo studio. It's all right here.
It's air conditioned, which is really
great.
It's
really hot in New York right now.
It is. We have a lot on the show today. Tell them what's on the show.
That's right.
First.
I will.
Okay.
Tonight's code is Blinky. All the things that you like to do that blink, we got them 10% off in the Adafruit store if it's in stock.
We have the most Blinky.
As seen on the show and tell, we'll go over some awesome, cool projects in the show and tell.
Some of which were Blinky.
Lady Ada has been turned into an anime. GitHub has some license help when you need to choose license for your project. We'll stop into some Kickstarters from our friends out there. Barbie Goes Goth, very cool. Cats of Engineering. We've got Packet of Mailbag. Things from the Adafruit Learning System. Checking in on the Summer of Solar. Wearable Wednesday. 3D Thursday. Pi Day. We've got new products. We've got top secret stuff tonight. You guys are going to love this. We're going to answer your question. We're going to have a trivia question. All that and more on Ask an Engineer. That's right. Okay. It is very hot in New York.
It is extremely hot, but we're here. We're alive.
Yeah, and one of the things that's interesting is with summer comes solar projects. So we're going to talk about some solar projects later tonight.
It was very easy for me to test solar panels. I was doing some solar testing, some analysis this week. And yeah, it was like super easy because it's just like sun all the time, every day.
That's right.
12 hours.
Let's pay some bills. The code is Blinky, 10% off anything in the Adafruit store.
Not just Blinky stuff.
Yeah.
Also solar stuff.
Anything that's in stock, 10% off.
Yeah, if it's in stock.
Yeah.
10%.
We just got MakerBot Adafruit editions. That's a really good deal. If you're ever thinking about getting a 3D printer, you get 10% off, and we already put in all these kits. And you get free UPS ground shipping if you're in the US.
So you get 3 in 1.
Yeah, it's a pretty good deal.
You should get one.
Yeah, and then we always have...
and just get our custom engraved plate, which you can't get anywhere else. It's like super custom.
And the other thing that we do is, which is always true, is any order over $250 gets free UPS ground. Yeah. In the US.
And there's a Pi in the kit too.
$350 is when they hit the free Pi level. Yeah. So we've always done this. It's we used to put a banner on the side, but everyone kind of knows now. So people are like, oh, I spent $300. I may as well toss in something else. I'll get a free Raspberry Pi. Yeah. It's one of the things that we like to do because then people start tinkering around with the Raspberry Pi and like, oh, this is a cool product or project and thing. I probably wouldn't have got it otherwise. So that is that. First up on the show and tell. We do the show and tell every week on Google Plus Hangouts.
That's right. We just finished it up.
Yeah. Lady Ada, what was on the show and tell?
Show and tell was super sweet. We had Scott from Garlic Software, who's got an awesome lower third bar. Scott G showed up, and he's been doing some BTLE hacking. He went to some developer conference at Apple, and he checked out
the Apple Developer Conference.
Okay. Yeah. Sorry, not just some developer conference, the developer conference, and he checked out these iRemote beacons, iBeacons, I don't know. Yeah. And he got one, and he took it home, and he's like, I wonder how this works. It works with iOS 7, and it can like detect the distance of these beacons, and it like runs, it doesn't even connect to the Bluetooth Low Energy. It's actually just like a little beacon thingy. He's like, it's kind of interesting. So he reverse engineered it using a CC2540 Ti Bluetooth sniffer, which is kind of cool. I didn't know that Ti made a Bluetooth sniffer. I'm going to check that out. And he sniffed what the advertisement packet was for this Bluetooth, and then he programmed his own module with this packet. So yeah, that's kind of cool. So you can make your own little iBeacons now without having to buy specialized hardware. You just DIY it. William and Jen, who recently got married and had an electronic wedding, showed off their really cool electronic bow tie wedding favor thingies. Had a glowing LED, it had a little battery. They gave it as a wedding favor to all their guests. Guests wore it. It looked awesome, I'm sure. And then there was also a spectrum shield, a little spectrum shield that uses a spectrum analysis chip to then like make little blinky things happen. And then Jen, who is William's best friend, showed off her cool necklace. It was a 7-segment display, which then they hand soldered like they hard code soldered, so it said 42 on it, and it's like, there's no microcontroller, it's just battery powered. And it's actually kind of cute. It's a little like square necklace, and it just says 42. You customize it to have any of your favorite digits. Your lucky number from 0 to 99. We also had Sally, who just stopped in. Sally's got a really cool coat, though. She's photographing.
She's going to photograph. LEDs are hard to photograph. And she sewed in 53 Flora RGB NeoPixels.
She's got a coat with like 60 Flora NeoPixels, which will work if you can wire them up.
Yeah.
And she's going to take a photo at some point. And then Raymond showed up with Clifford, the annoying robot. That's actually what the robot is. It's annoying. It just bumps into people. And he showed off some like cliff detection stuff he did with it. And then he's like, he had DC motors, and he's got like a ping sensor. And now he's going to upgrade it to a bigger 4-wheel drive sort of tank tread base. That's kind of cool. We had, they were some pretty sweet projects.
Yeah, this is good stuff. Lady Ada, how do people get on the show and tell?
Getting on the show and tell is easy. Go to our Google Plus page at plus.google.com/symbol Adafruit and find the page where I say, hey, comment here, and I'll add you to the show and tell circle. Comment there.
Yeah.
I add you, and then every week at 9:30 p.m. Eastern Time on a Saturday, you will get invited to show off your cool project. So if you have a project, comment up. We'll add you.
Yeah, if you look on our YouTube page, youtube.com/Adafruit, you can see like 73 or something hours worth of show and tells, because each one's a half an hour.
Yeah.
That's a lot.
That's a lot of show and telling.
We've been doing these for a while, so if you like the vibe of like a maker fair or your hackerspace and you want to kind of experience it anytime, just hit the playlist and you can watch all these cool projects. What's neat is there's people that have had projects and they come back over time.
Yeah, and if you have a question about your project, or you want a suggestion or something, a lot of people are like, hey, I want some help with your project. If you show on the show and tell and you ask a question, I can actually like look at what you're doing.
Yeah.
Because a lot of people say like, I need help with my project, Lady Ada, and I want to call you on the phone. I'm like, I really can't. I'm really busy. But if you show up on the show and tell, it's dedicated half-hour time.
Yeah.
It's like office hours.
Yeah.
Show and tell and office hours.
Yeah. We've actually helped people with their projects over show and tell. We try to keep each, if there's like,
as long as it's like, within 2 minutes.
Yeah, if there's 7 people, we try to make sure each person gets time. Next up, anyone's on the show and tell also gets an as seen on the show and tell sticker.
It's vinyl.
Yeah.
High quality.
Okay. Lady Ada, here is a fun picture. Last week we had Charles and Hannah and Cynthia and Nancy on the show.
That's right.
And Cynthia,
we had a gaggle of engineers.
Yeah, and Cynthia drew this of you. This is the little Lady Ada anime. A lot of people may know her from our post on our site. She did an Arduino anime character and an XP anime character. Well,
in Japan, like, they know every company has a mascot.
Yeah.
Pretty much, right? I mean, I'm usually more cutesy, but like there's mascots for everything, and we don't have that here. That would be cool if we had. I mean, we have like AdaBot as kind of our mascot, or MOSFET, depending. But like
depending on the company, there's like GitHub has the octopus.
Yeah, but that's really weird.
The cat octopus. You never. Really
I've never really liked it. But
speaking of GitHub,
I like GitHub. Just the octopus is kind of weird. I don't get it.
Yeah. You don't get it. Speaking of GitHub, that's what they call a transition in the biz. Ooh. Speaking of GitHub, so one of the bits of feedback that GitHub always got was let me back up. One of the problems that people said is they put their code up on GitHub and they never choose a license. So therefore it's like, well, who knows what you can do with it? Kind of nothing. So they came up with this thing called choosealicense.com, and it'll actually tell you what license that you should choose. It'll help you, and it'll ask like what describes the best. What best describes your situation? For Adafruit, what license do you tend to like the most for your code and your hardware is a little different?
We tend to go with MIT license or BSD license for our code because it's the most permissive.
Yeah. In other words, you want people to use it and make businesses with it.
Yeah, that's true. Some of our code is under the GPL. If we think that makes sense, if we think that people can contribute back, we'd like people to contribute back, we'll do a GPL license. Mm-hmm. And then for hardware, we do Creative Commons Attribution Share Alike, which is kind of like a GPL-like license. But those are the kind of 2 I've used so far. I haven't really used Apache. We do have some stuff under the Tapper license, the CERN Tapper license, but I think that's... I tend to use MIT. I tend to use MIT BSD license, or in some situations GPL.
And then for hardware, the origins of open source hardware, we all kind of just said, there's probably not going to be a license, like really, so like let's just show intention, and it was Creative Commons.
Hardware is a little more complicated because there's multiple layers, and each layer has different licensing considerations. And also there's some layers that can't be licensed. Like you can't really license a schematic except for a patent, and that patents are not very compatible with many of these licenses. So yeah, it's kind of, I think Creative Commons Attribution Share Alike is the best way to show intent. Yeah. I think intent is actually the most important part of a license. Yeah. More important than any legalese, because like the thing is there's, you know, like some countries may not even, there's some countries that don't have the ability to use some of these license effects. So you might as well show intent.
Well, CERN is working on an open hardware license. There's a Tapper one, and still to this day, the most popular way that people share hardware using an open source license, or they're showing intent, is Creative Commons share alike attribution. And Arduino's under that. Yeah. Probably the most popular open source hardware project that's out there.
Yeah, it's interesting because Arduino couldn't have really started without processing, which is, you know, the software that's also under an open source license. So it's actually kind of, it is building upon layers of other people's work, which I really like. It's like processing, you know, made this IDE, which was really difficult. And then Arduino was very lucky. They had the processing IDE, which did take modification, but it wasn't like starting from scratch. Yeah. So I think that makes it like, you know, that and wiring, like all of these groups together, working together and contributing back. So all these licenses are really good. I think they all have pros and cons. You know, with firmware, if I'm releasing libraries for our products, I don't know what our customers are going to use it for, and I think that GPL with firmware, it's a little bit confusing. Yeah. So it's like, where do you put the notice of like where to download the firmware, and it's like it doesn't come on a CD or zip. You know what I mean? It's a little more software. You can only you distribute as bits, but hardware, the firmware is burned into hardware that. Yeah. But you're not going to give a USB key or a CD-ROM with it. So like a URL, if the URL goes down, it gets complicated. So that's why I think BSD license, MIT license is pretty good too. That way, just the attribution stays on the library header.
Okay, that makes sense. Yeah. Next up, we normally don't post Kickstarters on Adafruit because what happens when you post a Kickstarter on a popular site, every Kickstarter then is just constantly pitching you and
we already get like 20 Kickstarter Indiegogo requests.
We get about, I'd say, 20 emails on average a day of people who it might even not have anything to do with like making electronics. And the thing
is, I don't want to post Kickstarter because Kickstarters are you're investing in the person.
Yeah.
I do feel like if we post a Kickstarter, it means we are in a sense not just promoting, but like lending our experience and like what's it called, the like not promoting, but like we think that these people can actually finish the project.
Yeah.
What's the word?
Well, no, it's.
I don't even know the word.
Well, I know what you're saying. If we post a Kickstarter.
I'm not condoning, but like.
No, it's saying that we believe that they're going to finish a project and ship.
Yeah.
And historically.
Our reputation is being tied to theirs.
Yeah, and if they say, oh, I saw it on Adafruit, and they never get their thing that they backed, we'd feel bad about that. However, there are a couple that we will, and these are friends and people that we know really well, and we know
where they live.
Yeah.
And if they don't deliver, we'll let them know.
So the first one, Gareth has recently retired from Make. When I retired from Make, Gareth took over running the Make blog, and
Gareth's a great writer.
Yeah, and now he has like 30 years worth of writing. He's been writing for a long time. So now he has a new thing, Borg Like Me, collection of all of Gareth's stories. Super cool stuff from when he did one of the biggest HyperCard projects ever.
Love HyperCard.
A CD-ROM thing with Billy Idol, just like tons of stuff, tons of writing from.
He did the CD-ROM with Billy Idol?
Yeah, I believe.
Man, I didn't know that. Yeah. Gareth's cool. So, I remember that, the libido thing.
Yeah, so there's a lot 90s. Of stuff. Watch the video that he has. But this is a Kickstarter we posted about because Gareth has excellent follow-through.
Gareth is the original cyberpunk.
He is.
He is the cyberpunk.
He is the cyberpunk.
And he's like half robot. I can imagine him being like, I have a robot exoskeleton now.
Yeah. And so that's one. And the other one that we're really happy about is Lenore and Wendell emailed us from Evil Mad Scientist Laboratories. They've been working with maker Sylvia, super awesome Sylvia. And they came up with a watercolor bot. And they sent me an email. They're like, hey, do you mind posting this up? And I said, oh, absolutely, I'll post it up. And I think you should ask for more. Because they showed me a preview of the Kickstarter, and they didn't. I always think, people that like them are going to be super successful no matter what they do. Sky's the limit. So they already hit they don't need any promotion at all.
Yeah.
We posted up on our site anyways. And Sylvia was on, I believe, the Today Show, showing off the spot.
Katie Couric.
Or Katie Couric, sorry, I get this confused. That's kind of reasonable.
It's not The View. That's
so here's the watercolor robot. And
it says XY gantry.
Yeah.
It's got stepper motors. It's got servos. It's got a little paint set, like the standard paint set that you get for like a couple bucks at the store. And it comes as, I think, a semi-kit.
Yeah, and I have a video.
Okay,
so we're going to actually play the video here on the show. And after you see this, go and consider backing it. This is going to be really cool.
Today we're really excited to tell you about our new project, the Watercolor Bot.
Hi, I'm Sylvia Todd from Sylvia's Super Awesome Maker Show.
And I'm Wendell Oskay.
And I'm Lenore Edmond, and we're the founders of Evil Mad Scientist Laboratories.
What is the Watercolor Bot? The Watercolor Bot is an educational robotics kit that can paint with watercolors. I came up with the idea for the Watercolor Bot because I wanted to create my own robot and enter it into the Robo Games competition. To actually design the robot, I worked with Wendell and Lenore, who already make other kinds of awesome robots. Once we started building it, and once it started coming together, we realized that other people might like to have one as well. So we started building a kit version of it. Once we had the prototypes working well, we took the Watercolor Bot and showed it off at RoboGames and Maker Faire. I was also invited to bring the Watercolor Bot to the White House Science Fair. President Obama really seemed to like it. The Watercolor Bot comes as a kit with some assembly required. Young kids will need some adult help to put it together. You will need small and medium Phillips screwdrivers, scissors, and a computer. To move the brush, there are 2 motors built into the frame of the robot. Each motor drives a little winch that moves the length of cord attached to a rod that controls either the X or Y position of the brush. This is the same mechanism that an Etch-a-Sketch uses, but instead of a stylus, we have a carriage that moves the brush up and down. The Watercolor Bot uses a regular set of watercolors and uses standard 9x12 watercolor paper. You can make a drawing on the computer for the Watercolor Bot to paint, or start with existing vector artwork.
We will be manufacturing the Watercolor Bot right here at our shop in California. The main chassis of the Watercolor Bot is cut from American hardwood plywood with a CNC router, then sanded and laser engraved to provide the markings. We're launching the Watercolor Bot on Kickstarter for a few different reasons. The most obvious reason is to finance the initial manufacturing run, but we're also really excited about the Watercolor Bot and we want to help it reach as wide of an audience as possible. We think that the Watercolor Bot has enormous potential for STEM and STEAM education, especially as a way to get young people engaged with hands-on technology and robotics.
Okay,
right.
So that's a really cool project. It's, there's been 3D printers on Kickstarter. There's been laser cutters. There's been the other fab. We were backer on that.
Yeah.
From Mike Esty, who is here on our show, actually.
Yeah.
And now there's the Watercolor Bots.
That's right. I like it.
We like art bots.
I like art bots a lot.
Yeah.
So, and this is really neat. And I know they've been working on this for a really long time. And they've got the shop bot and the laser cutter. They have all the tools. So it's like they can actually pull this off. Like the egg bot is an art bot. So I think that like they can own this art bot thing.
Yeah. Very cool. Okay. Next up, this was a cool, quick thing that I wanted to share. So this was on our blog. These are the...
what are these called?
They're calling them goth Barbies. They're from Mattel. It's actually not Barbie, but it is from Mattel. And here's a quote about these. The message about the brand is it's really to celebrate your own freaky flaws, especially as bullying becomes such a hot topic. It's Kathy Klein. She's in charge of marketing for Mattel's girl brands, and sales have surged 56% thanks to Monster High. That's what they're called, Monster High. And Mattel had no idea Monster High would, in just 3 years, become a $1 billion brand. We just noticed girls were in a darker goth fashion.
I don't think these girls are really flawed. They look like they're like 6'3" and weigh 100 pounds, but the fashion's really good.
Yeah, I thought it was neat that this is one of the things that we're starting to see is more of the kind of gothier Comic-Con stuff kind of bubble up into mainstream. Zombies are kind of here. Comic-Con San Diego is going on right now.
Yeah.
And it's totally fine. And I remember when we were first starting out, it was like, oh, like Adafruit's like gothy electronics company. And at the time it was weird. Now it seems, like it's fitting. So
we are the gothy electronics.
We are the gothy electronics company.
I like it.
Yeah.
More stuff in black.
Next up, we posted some Cats of Engineering photos every week. People send us pictures of their cats doing engineering or sitting on.
I guess this one's doing software engineering.
Yeah, this cat has a lot of cool tools.
This one is soldering some stuff up, like an old paste soldering iron.
So send your pictures of cats
you have a cat?
to support@adafruit.com.
Would you take a dog of engineering?
It's called Cats of Engineering. I don't know if you saw the URL. It's adafruit.com/Cats of Engineering.
So like a ferret with an oscilloscope doesn't count?
Cats of Engineering.
Okay.
Yeah, other companies have ferrets of engineering. We're not that company.
Yeah.
Cat company.
Okay.
Okay, next up. Pack of the Mailbag.
Do we have a Pack of the Mailbag song yet?
Not yet. We're getting there.
Working at it?
We'll get there.
Okay.
Yeah, so Pack of the Mailbag. Every week we read letters off from the website. We have a backlog of these, so we just post them every week. This one was from a while ago. This one is from, hey, Lady Ada. This was the fellow's name, I think, was Cliff. First of all, I hope all is well with you and yours after these couple storms we've been through. This is right after Sandy. I wanted to thank you for making those great skill badges for kids. My daughters, 9 and 7, are hooked. At around $3 a pop, it's a great little motivator for them to learn some pretty neat, fun stuff. Plus, it's a dad and daughter time at its finest. I was looking at a way to make electronics programming fun for them, and it's also given them a reason to drive on when things get a little tough. Problems always seem to pop up along the way. In code and circuits, the badges work as a great goal. My oldest wants to know if you've ever made a scratch badge. Yes, we did.
We did.
Squishy circuits, sort of, kind of, and a 555 timer badge. We probably will.
Probably will.
Yeah.
We have We have the plushie.
Yeah, we have the plushie now.
It's kind of like a badge, big badge. You could duct tape him to you.
Yeah. Next up. Adafruit Learning System. Lots of things went in the Adafruit Learning System
Yeah,
this
I had
week.
some time on like Tuesday, and I cleared out a whole bunch of tutorials that we have been migrating over.
What are we up
from
to, 265 or something?
Yeah, like 270
270.
almost.
270 tutorials.
We have about, I think, 10 more tutorials to migrate from lateData.net.
Yeah.
And then but we have some, so we have altogether, like 270. We'll probably have 300 within like a month or two.
Yeah.
2 or 3 months.
Okay, so what is this one right here?
This one is, this is a new tutorial by Justin Cooper, who is doing awesome stuff with Beagle and Black. I said, hey, can you help me out? Check out Beagle and Black and adapt some of our Raspberry Pi tutorials to the BBB, or the triple B, as I like to call it. And so this one is how to add a real-time clock to the BeagleBone Black. So the BeagleBone Black, like many of these low-cost Linux computers, does not have a real-time clock in it. That means when you turn it off, it forgets what time it is.
Okay, so Raspberry Pi doesn't have a real-time clock?
Also, the Raspberry Pi does not have a real-time clock.
Okay.
And you don't really need one. If you have internet activity, if you have internet connectivity, for example, if it's plugged into Ethernet or Wi-Fi, it'll actually get time from the DHCP server. So when it connects to the Wi-Fi or Ethernet, it'll actually get the time, and as long as it's connected, it'll know what time and date it is. But if you want to have a project that's not connected to the internet and you want to be able to turn it off and on, have it do an alarm type thing, you'll want a real-time clock.
So data logger, you would need to do a real-time
data
clock.
logger thing, or something where it's like every day at 6 I want you to turn on a servo or play a sound or something.
Yeah.
So a lot of these time-based projects, you'll want a real-time clock, and they're not too expensive, but to save costs, they were taken off the board. Anyways, we have a really lovely kit. It's very easy, follow the instructions, and you can add a real-time clock. It's actually very similar to the Raspberry Pi. We just adapted the instructions for the BeagleBone Black.
All right, next up, I'll take this one. We put our tutorials up, shop tips and tricks, things like measuring scale.
This is the best measuring scale.
Yeah.
And actually, later on, I found out that Lenore and Wendell have the exact same scale.
Yeah.
This is a great
and
scale.
So we like to share all the things that we do to run the Adafruit factory. This is also a look back in time when we were running Adafruit just out of a small apartment. So these are all the things that got us here, and we like to share this stuff. So that's a new tutorial.
Yeah, this is a great scale.
Yeah, the next one up, we updated the USB Borduino tutorial
DC
and kits.
Borduino. Yep, those are updated. Those are now on Learn.
Yeah. And then next up, another BeagleBone one. Maybe you can talk about this one.
Yeah, this is a servo. So the BeagleBone, we did, I think, PWM already, PWM for like LED blinking. But one of the cool things about PWM is if you can control the pulse width and the frequency of PWM, you can control a servo. Servos require about 60 hertz and 1 millisecond pulse widths or so. And this tutorial just shows you what commands you use with our Python library in order to control the PWM, to control a servo back and forth. And you have a couple PWMs in the BeagleBone, which the Raspberry Pi does not. So if you're looking to control servos, we have a servo add-on board that can control 16 servos, but the BeagleBone Black does have the ability to control a couple, I don't know the exact number, I think it's like 4 PWMs right off the board, as long as you provide external 5-volt power.
Okay.
Good to go.
All right. Next up, we also have how to earn a solar badge. So speaking of badges, this is part of our Summer of Solar. And this is a solar badge if you go through a bunch of projects. And this was written by Adam Kemp, who's coming out with a new book soon, The Maker Workbench.
Oh, that's cool.
Yeah, and so...
I don't carry that book.
Fun story with this. I introduced him to Make, because I thought he was a really good author, and they worked together, and this is the book that came out of it.
Yep, he wrote a couple of requirements badge docs for us, and we released them. I think we released a couple others too, but the solar one, check it out. It's all good. Yeah, and then last up, we updated the Mini POV tutorial. Mini POV 3 tutorial is now on the learning system. So yeah, just adapting these old tutorials. We're going through and putting them in the learning system to make them more mobile friendly, make them so you can download PDFs, make them, bigger images. The image quality is much better on the learning system. So overall improvement, and having one place where we can have all of our tutorials. Great. Next up, Wearable Wednesday. Every Wednesday on the Adafruit site, we celebrate the world of wearable electronics and more. One of the most popular areas of our site now. Wearables is big. Next week, there's a wearable conference in New York. There's like one every few months. There's so much going on in wearables. We made a big investment because we thought wearables needed an Adafruit to come along and help get things like Flora, the NeoPixels, the conductive thread that's just made for us. All these things to make it really easy. Sensors, Sobel GPS. So this is all happening. So we're celebrating a lot of the projects that are on the site that people are making or sending us in. And then also we have other stuff. Converse has a new Converse hacking page. And they want people to hack Converse, share all the things they did with it. And one of the projects they have on there, the first project they have on there, is our glowing chucks. That's right. That we did. Next up, Nike is showing off some stuff. I just posted this up because this is almost going to be my Halloween costume. This is almost a Dune still suit right here, but this one lights up. It's a padded vest, and it also lights up. It's really neat. It's kind of cool. Nike's doing some really neat stuff. And then the next thing... It's very beautiful. Yeah. Nike makes beautiful... Their concept stuff is always amazing. Look at this. Get your more deep on and go for a run. And then the other thing I wanted to show is I showed a preview of the color piano, and that's a Flora that I took, and I have a color sensor and an LED and a piezo, and what it does is it plays music based on the color it sees. Yeah. Colin, who's an awesome musician, and Colin came in and was like, I can do this better. All around awesome, used our little music board, our codec board, and then an audio amp, and so we actually did another little prototype. So we're working on this. It's going to be a real musical instrument that you wear that plays colors. So let me show this. All right, here's Colin on the color piano. That's our little playing the rainbow. All right, here's Colin on the... So that's cool stuff. Next up, Becky did we have a new series of videos that we're doing, wearable electronic teardown. So if something's wearable or something's really cool, we take it apart, you come in and you're like, here's how it all works, here's the crazy chips, and like, I read data sheets for fun. That's what you sound like. There's nothing wrong with reading data sheets for fun. I read a great data sheet last night. And so these are the cat ears that will change and move around based on your emotions. Yeah, this has an EEG, and it moves the ears based on your brain waves. If only there was a video. Oh, wait, there is. Oh, a video. Yeah.
This week we're tearing down the brainwave cat ears from Nekomimi. They're a really cool headset with a brainwave sensor that touches your face, and then the ears wiggle according to your brainwave activity. They supposedly show when you're alert or when you're distracted, and we had a lot of fun trying them on before taking them apart. To disassemble the Nekomimi cat ears, I found some screws underneath a sticker in the interior, and then pried the rest of the plastic apart. The 2 servos that turn the ears are connected to the main circuit board with these 3-pin connectors, and to walk us through the chips and the hardware on the board, here's Lady Ada.
It actually comes with 2 circuit boards, and we detached them. They were soldered together. That's pretty common when you have sub-assemblies, like one part's used for multiple products. So, or they want to save space, so they'll have 2 circuit boards and they're soldered together. So this is the actual brain sensor EEG interface, and there's this nice flexi wire connector. And inside are 2 fine wires that connect to this, and this is the EEG interface board. And then it connects with 4 pins to this board. All this microcontroller does is probably get data from the EEG board and then just translate that into, what motions it wants to move the ears into. So let's check these out in detail. So these are the 2 analog inputs. So you've got, this is the ground ear clip connection, the reference voltage, and this is the EEG input. You can say that they solder these and then use a little bit of hot glue to mechanically connect them, which is pretty good quality. And then here's the NeuroSky chip. So it's a TQFP48, and it has NeuroSky actually lasered onto it. Now, this might be a custom chip, a completely custom ASIC that they designed, or it could actually be some other companies such as TI or Linear Analog. They have a chip that does nearly anything it needs, like DSP, analog input, microcontroller, and it's customized enough. There's enough firmware modifications that they actually got the company to put their own laser markings on it. That's not unusual. I've seen that a couple times. If you're ordering like 10 to 50,000 of these chips, that's something that you can request to make your product maybe a little bit harder to reverse engineer, or just kind of add a little bit of pizzazz to the circuitry inside, because it's customized. And then here is that connector. It's just a basic solder connector. Also looks like there's some parts here that were not attached. So you can see that, at some point in the future, in the past, they're going to have another version of this EEG interface board. And on the back, you get a lot of passives, a lot of markers. Looks pretty good to me. Nice design. And then it attaches to this board. They want to keep the cost low, so they'll go with sort of a generic microcontroller, an 8051 core. So that's probably what this is. It's like a 50-cent microcontroller. Not a lot going on here, so probably save them 50 cents, maybe $1 on the bill of materials. Crystal that goes with it. A couple of parts. This is probably the battery management, cleaning up the power for the microcontroller. And then here are 2 nice little connectors for the servos, 3-pin connectors, plug in the servos. This makes it easy to assemble and also repair. And then over here is some unconnected pads. Almost certainly this is the microcontroller programming interface. So you can pogo pin, program it, and then you put it into the product. So yeah, this is a cute little board. I really like it. It's a super nice circuit board, very thin, but really well designed. I can tell that whoever did this cared deeply about it. Reset button on the back.
For this and many other teardowns, we use these Adafruit tools. If you've got an idea for a cool wearable like these brainwave cat ears you'd like to see us tear down, post up in the comments, and I can't wait to see you next time.
Okay, jumping right back in. Next up, 3D Thursday every week on the blog. Tons of 3D things. This week, my picks.
3D Thursday is you guys are becoming a powerhouse.
Yeah.
Of 3D stuff.
I'm noticing other sites are doing 3D Thursdays now. It's catchy. It's catchy.
I just like you guys are like actually getting the most cool stuff. Like I'm not involved in 3D Thursday like I do Wearable Wednesday.
You have nothing
more,
to do with it.
But it is. I know everything about the 3D printing landscape.
Yeah. This week, my favorite picks. There is a functional Lego 3D printer. This is really neat. The other thing, this is an action figure, a 7D point articulate.
Yeah, this is cool.
Yeah, so people, this is the future, right? So what's coming up next? Well, you'll probably download the action figure you want and then print it out.
I love the quality here. This is really beautiful.
That's really good. And then next up, someone printed out some accessories for Google Glass that I thought was funny. So
I love these. Yeah, these are funny.
Air, and then it's like, well, perhaps I would like to grow a little plant on the side of my head.
I like that.
Yeah.
Little plant.
So that's it.
Then there's a pencil holder too. I like that.
Pi Day every Friday on the Adafruit blog. We have everything in the world of Pi. I thought this was neat. This is it's also a 3D printed project, but it's a Pi project. It's a little printed retro arcade player. So you put all this stuff together. This is stuff that we also sell at Adafruit.
Yeah, there's like our 7-inch screen. Yeah. There's a little our wireless keyboard and our SNES controller. So yeah, these are some fun projects.
Yeah. And the next thing, there was a really cool tutorial on how to run and use Scratch on the Pi.
Yeah.
So we put that in there. We also have a Scratch badge. This was one of the things that someone asked earlier, and we did that. We got permission, and we have scratch badges. So that's kind of neat. Before we go on to the new products, I just want to talk about the code. The code is Blinky. Blinky, and that gets you 10% off everything in stock, including the things that we're about to see. So, Lady Ada, it is new product time.
Hit the song.
Yeah, we got a little song thing. Okay, so first up, we have some reshoots. For the folks who watch our site closely, we're redoing all our photographs.
New photos.
Yeah, so and these are just like good products to introduce. Again, this is our FTDI friend. These are some of the new photos. John Janier is taking some beautiful photos that really show how I think great your designs are. This is.
You can see retrace now.
Yeah, look how beautiful this photo is of the FTDI friend. You can just see it.
You can see a really good pick and placing. Look at that part.
Yeah, and then we have the Minty Boost. And the Minty Boost, we wanted to show that it works with the iPhone 5S. We have a black iPhone, a white iPhone. We have it charging, so you can see that it's actually charging, and then all the different parts, and then of course the Mint tin itself. That looks really nice.
Yeah. Nice.
Back in stock, the
Sous vide Duino.
The Sous vide Duino, it's its nickname. But basically, if you want to cook food at a constant temperature over a long period of time,
yeah,
it's called sous vide.
We have a little controller kit.
Yeah, we have a little controller kit that you can get now. And then of course, new product.
New product. Okay,
we have goggles.
We have goggles. So these are
the goggles. They do something.
They do something. These are actually kind of neat. They are. Let me turn them on first. These are video glasses goggles, and they're kind of, they're some people are like, Phil had a Sony Glasstron. He's actually showing this to me, and I was like, I wonder if there's something similar that you can get nowadays, but isn't like $1,000. And we got this basic pair of video goggles, and then just to be clear, I don't think that they're actually that comfortable to wear for long periods of time. They're kind of heavy on the eyes. I mean, maybe if you're leaning back, it's not so bad. They do work really well, which I was surprised. Yeah. Like the optics actually works quite well. It doesn't look like you.
I'm gonna try to show it on the overhead.
Yeah, I'll show it off on the overhead in a second. But I just wanted to show you're basically wearing it, and it looks like there's like a screen right here, and it's kind of the sunglasses make it so that your vision is mostly darkened, which is kind of nice. And this is the actual vision system, and then the glasses themselves don't do anything. They're just like the holder. Like putting these in ski goggles would actually probably make a little bit more sense. And there's a little headphones, and there's an adapter. And yeah, let's try to check this out on the overhead.
Okay.
So I plugged this into a Raspberry Pi to demo, and I just want to see what happens if I hold this up.
Oh yeah, look at that. You can see the Raspberry Pi.
Yeah, hold on. I'm getting there.
So folks want to know if it's 16 by 9 or is it 4 by 3?
It's 4 by 3. I don't know. It's 320 by 240.
Yeah, but you can see it. Yeah, you just have
it's
to
just
tilt,
really hard to
tilt.
There you go.
Yeah, you can see it.
So you can see one eye, and then over here you can see the other eye. And I just have it showing off the if you had two vision glasses, you'd actually be able to see. It's stereoscopic, like it actually lines up in your vision.
Yeah.
Sorry, can you?
Oh, you want to go back over?
Yeah, sorry. I just want to show some more things. Okay. It comes with a little battery pack that has a cable, and then there's sort of a standard composite audio, which I just left out. The audio is just a little amplifier board that goes to the earbuds, but then there's a standard NTSC PAL audio. It automatically detects whether it's NTSC or PAL, and that works pretty well. And yeah, so it'll work with like anything that has composite out, and it's 320 by 240. But what I think this would be most useful for, because you can see like you can remove the video goggle part from the glasses, which is this part. And I thought this would be cool to either put on like ski goggles or something, so it's like more like something you actually wear. Or I'm pretty sure you could cut it in half and take one half of the optics, because the reason I was actually kind of looking into this is I was wondering if I could get the optics that's in the Google Glass, the display and optics. And I found the company that makes the display Google Glass, and they're like, it's $500 each. And I'm like, I think I'm gonna find something else.
Yeah.
So this is not as elegant as like a Google Glass type heads-up display, but I think we're gonna do a teardown of it to check it out. Yeah. But I got these to start. I think this does have some potential for hacking or modification, and it's like $100.
Lots of people wanted to do a a wearable Raspberry Pi, this would be something you could do.
You could like maybe use one and have it on like a flip top or like
Yeah.
attached to a hat. So this I think has a lot of potential. And again, it's like it's not a $700 Glasstron,
Yeah.
so like or $500 Google Glass optics piece. So yeah. Fun for hacking.
Are you able to see it with because you have eyeglasses on?
It does not work for people with eyeglasses unless you keep the eyeglasses on.
Okay.
For reasons that I'm not an optics person, but because of the way that it works, even though it's right next to your eyes, it appears to be like the TV appears to be like a couple feet away, and if you don't, my vision's particularly bad. If you have fairly good vision and you can see a TV from a couple feet away, it'll probably be okay. But I just put a warning. It's for people who have corrected vision or contacts, or their vision is pretty good.
Okay. Next up here.
I have no idea why that thing with it.
Yeah.
It doesn't make sense to me, but I'm sure there's some math with rays converging. I don't know.
Math. Okay, next up.
USB tester.
That's right.
This one's really cute. It's actually a person who was selling on Tindy.
Yeah, we thought it was a cool design, so we stocked it.
Yeah, and they were using our OLED display to make sort of a more complicated version. I was like, you know what, it's actually kind of handy because I was doing a lot of USB voltage and current testing. So this splits the voltage line in half, and then you can see there's like these connectors, and it comes with a jumper, so you can re-jumper it, but you can test voltage. You can plug into the D plus D minus line. It's just a little accessory. It's just like when you're doing USB testing and you want to because voltage can fluctuate a lot from computer to computer. Like my desktop here gives me 4.7 volts, which is really low, 4.8 volts, and then my computer at home gives me like 5.2. So this is a way to actually get good measurements on current and voltage, and it just works with any multimeter.
Okay. Next up. This beautiful board.
Yes, little PWM board.
Little PWM board. And what does this do, Lady Ada?
This, if you leave it right there,
I'll leave it right here.
Right there. It's a 12-channel, 16-bit PWM board. It uses an SPI type interface, clock in, data in. It can run up to 17 volts DC, and it can do like a chain of LEDs, which is really handy. It is constant current. Which is really good. So you can set the current, I think by default set to like 16 milliamps or something on the board, but you can change that with a through-hole resistor. You can chain them as many as you want, and it's 16-bit PWM, which is rare. Usually you see 12-bit PWM, maybe 10-bit, but this one's 16-bit PWM, which means it's extremely good for if you want to have very precise PWM control. It has an internal clock, which is really nice too. So you just turn it on and it just basically runs. But it also means it's not good for servos because the clock isn't set to 60 hertz.
Okay.
So not good for servos, excellent for LEDs, can drive 12 LEDs. It's very compact, fairly low cost, completely chainable. I've got Arduino code ready to go. Just these two digital pins.
Okay. Next up, and this is the last new product of the
Oh, and it has a built-in low dropout regulator too, which is very handy. It has a 3.3 volt regulator cooked inside. But you can connect an external voltage if you want as well.
Okay. Oh, this is it. Look at this thing. Zoom.
Okay. TLC 59711.
Yeah. Next up, these are some boards, and why don't you go over to that computer right now, and you have a wireless mic, so you can start talking about it. This is kind of a new thing for us. We wanted to have some really cool LED walls and LED products. Here's a photo of it in action. Lady Ada's setting it up right now. Here's an Adafruit logo. Here's the blinkies that we had before.
Yeah, that's a video. It's actually really hard to video an LED wall.
Yeah, but let's go to the main here, and I'm gonna turn off the lights. So
I don't know. Yeah, it's really bright.
Yeah, we'll see how it goes.
Let's see what we can see. You can see the reflections.
Yeah, and maybe if you want to change it up a little bit to have some other things
I can change
on
it. Yeah. Oh, it's just really bright.
Yeah.
Let me change it to the hamburgers, maybe. Hamburgers.
This is the portion of Ask an Engineer where we dance.
You can see it.
Yeah.
So we're backlit. So you can see it is a video wall. But our video is really good. We'll show the video.
Yeah.
Right now it's just showing some dancing hamburgers.
Oh, I had already showed the video, the quick.
Oh,
snippet.
the little animation.
Yeah.
Okay.
The quick snippet.
Yeah, so we actually built a, it actually looks a little bit better with the lights on because it's not as washed out. So yeah, there's little dancing hamburgers. So this is a video wall. Actually, I will escape out. I don't know if this will work, but for example, I can, Let's see the Chrome logo. Let's see if this shows up. Does that show up at all? No.
It's really,
too bright.
Really blown out.
Yeah, well, we have a really good video. Unfortunately, we have nobody here who can help us with doing this kind of LED videoing stuff. It's basically a 2 foot by 2 foot LED wall, and we have these really cool LED panels that we've been carrying in the store. And I actually figure out how to hook these up to a microcontroller. And these are the panels that are used for like big style LED walls. And they're tiled together, one after the other. On the back, you can kind of see there's these arrows that tell you like which way to chain them. And when you chain them together and you control them with a special controller, you can actually turn into like a video wall. And the video wall actually looks like a screen. Yeah. Like the Mac actually is like you are connected to an external like HDMI screen or whatever. Yeah. So we have these in the store, and so I was looking at these and I was like, I should see like what do people, because I actually got these from like a factory that makes LED walls, and I was like, well, I should also see like what do people use to control them for screens. And I actually tried to do this with an FPGA in-house, and it was really hard. We have a little FPGA kit, and like it kind of was really difficult to do, and we couldn't really get video on it. And so I was like, well, I want to check out what people actually use. And so I got a set of these control boards, which are what are used to control video walls. And these are like actually like all video walls. Like I actually ended up later on going to a LED wall store, which is kind of odd. There's one in New York. And I kind of like peeked around and I was like, what are they using? And they're actually using basically these kinds of control boards. And there's one that has like, video in, and it transmits to another one, which is actual LED control. And they both have like super hardcore FPGAs on them, which I'll show in the overhead. Which makes them fairly expensive. There's a lot of electronics on here. Yeah, I'll get rid of this video goggles. I'll go here. So, let me get this. Okay, so this is the transmitter card. So it actually has these like contacts, which look like a PCI card, but they are not used. Like this connector down here, even though it looks like it plugs into a computer. It's only there for like mechanical mounting. Like if you want to put inside of a tower computer, you don't actually need to put in a tower computer because not many people have towers. And on this side, you've got, bring this up. So you've got a DVI connection. You can connect HDMI or DisplayPort to DVI because it all uses the same protocol. You just need an adapter cable, which are like a couple bucks. USB, which you use to configure it to tell it like how many panels you have connected, and like the width and height and like the setup and everything. And then these two Ethernet ports are actually how it sends data. It uses Ethernet, not Internet Ethernet. It's not sending like packets, like TCP/IP packets. I think it is sending like low-level Ethernet packets. Because Ethernet's a really good way to send data like 100 feet. And then on here you can see, this is actually kind of cool. This is the TFP401, which actually I've been playing with lately. It's a really cool chip. It converts HDMI signal to 24-bit RGB. And then here we have a Xilinx Spartan XC3S200A, which I don't know exactly how many gates or whatever there's in it, but it's a big FPGA. And then there's some buffer RAM over here. There's some SRAM. And then there's the Ethernet, I think this is 2 PHYs, and then the magnetics, and then sort of power supply stuff. So this is the card that takes the video and it converts it to 24-bit RGB, like real-time RGB data, 8 bits of red, 8 bits of green, 8 bits of blue, a pixel clock, H-sync, V-sync. And then the FPGA grabs it, and I don't know what it does with it, but it sends it over Ethernet to the receiver. And the receiver card also has a Xilinx FPGA. It has the same MAC-PHY because it's receiving the data. And then there's this Xilinx Spartan FPGA also. And then it has these outputs, and these outputs actually go to the LED wall contacts here. And these displays, the LED displays are very, very dumb. It's not that there's anything wrong with them, they're really basic. There's no controller in the LED panels. The LED panels are just matrix connected all together with some address lines and some drivers. There's no smarts in the panel, which makes the panels fairly inexpensive. So the panel, this is like $40 for like 200 plus RGB LEDs, which is a really good deal because there's not a lot going on here. They're meant to be completely replaceable, completely hot swappable.
Yeah.
You give them 5 volts, you give them the data in, and you're done, and then you can chain them. And so on the wall that we have back there, we have 18 of these panels chained together and connected to the receiver card, and then you just run some software to configure it. You have to configure it the first time using Windows. Unfortunately, you have to use Windows to configure it. It has a little EEPROM you have to set up, and somebody could probably reverse engineer it, but we don't really have time to do that.
So how much current does this thing draw?
This draws like at least 10 amps, because we tried powering it with 10 amps, didn't work. We have it on a 30 amp 5 volt supply. Maybe I'll try to point it out.
Right. And how many of these could you chain all together?
You can do, 1 second. There's a big, I don't know if you can see it, but there's this big power supply here. It's an old tower power supply, which can give you 5 volt, it gives us 5 volt 30 amps. I don't know what the heck people were doing with computers that they needed 5 volt 30 amps. Maybe it was a server rack controller. But yeah, it draws a lot of current. Each panel draws like an amp or two, but it turns into just a video display. And so you can connect up to, it's like 1920 by 1080 or something.
Yeah.
I mean, it can control a massive display. I mean, like you'd have to get all the panels. And we decided we wanted to build something using like the extruded aluminum that we have in the store, and it's 2 feet. And when they did the math, we're like, wow, that's exactly like 6 by 6 or whatever. So we just did or 3 by 6. It's 3 panels wide, 6 panels tall, but it's totally seamless. And other stuff you can do is you can like
oh, you have another little thing. We made an LED cube. We're not going to plug it in.
Yeah, this I don't have this set up.
This is a demo for showing on the show, but this is an LED cube.
So you can also take panels and connect them together, and we'll have a future tutorial about this, but I just wanted to show this off. And you can make an LED cube, and then you've got this little Ethernet cord coming out, which is that Ethernet cable that goes from the receiver to the transmitter, and then we have a little power cable as well. And so we'll probably like hang this up or something, and you can do full motion video. So the cool thing about these controllers is these controllers can drive massive displays. Unfortunately, there's nothing that's for like lower end. I mean, we have code that will drive like 1 or 2 of these little panels, but it won't do video. It'll just do like little animations or like text or whatever, like little drawings.
Yeah.
If you want to do video, you kind of do have to get these controller cards, and they're designed. The way it was designed is so to make it so the panels are inexpensive and the controller's expensive, because of these like massive FPGAs and this huge amount of RAM, and like they have to control up to like I don't know,
the side of a building.
So basically, they can control a side of they can control a side of a building, and it just plugs into any HDMI output, which is really sweet. So they are a little bit expensive, but the good news is that if you want to build a fairly large wall, you only have to pay for the receiver set once, and then the panels themselves are inexpensive, that's engineering, right? You have to do trade-offs. Yeah. You know, there's going to be costs somewhere.
Here, this is a cube. You can compare it to a Lady Ada.
Hello.
That's how we measure Lady
Adas. Yeah, and
we'll
show how we made this cube later, and these panels.
Yeah.
And you can cubify them with it. It actually wasn't very difficult. So this was a James DeVito project, and he did awesome. And check out the tutorial on the Learn system, because it's got all this detail and more.
And that is.
Do you want to just finish up with the?
Which one? I already showed these.
Oh, this one.
Which one? I did.
Oh, okay.
I did. I showed all this.
Right. I wasn't here. I was looking at the thing.
And that is new products.
Cube.
That is new products. Okay.
I love this cube.
We only have a few minutes left in the show, and we're going to try to answer some questions, but we promised that we would do It's Not Out Yet, Don't Ask, of a really exciting new product line. So I'm going to skip to that right now. It's not out yet, don't ask, but we're going to show it to you. So this is the new lineup of Adafruit Wi-Fi products, code name Wi-Fi Duino. Don't worry, we would never.
We're not going to call it Wi-Fi Duino.
We would never call a product Wi-Fi Duino. We only have one Duino sounding thing, and it's a Boarduino. And we'd asked Arduino a million years ago when there was only a few Arduinos out there, and they said sure.
Yeah, I asked Massimo and Tom for permission. I said, hey, is it okay?
I know they don't like that really now.
But at the time, that was the first one.
Yeah. So anyways, let's go to the overhead. And this is using the TI CC3000.
Yeah.
And do your thing.
Go in here. Yeah, so we've got a couple boards here. So I start always with like doing a breakout type board. And so, yeah, there's this little Wi-Fi module here, and it's that silver thing. And luckily we have this really awesome pick and place and reflow setup that can handle this, because there's no pads on the outside. The pads are all underneath. Makes it kind of hard to solder by hand. In fact, it's not really possible to solder by hand. You have to use hot air or reflow. So this is the breakout board, and it's got we use quite a bit of power. It's a little bursty when it does transmitting and receiving. It uses like 300 milliamps, and so we have a fairly big low dropout regulator here. We also have a 5-volt level converter because this is a 3-volt chip, and there's a nice antenna. The antenna is actually, even though it's a surface mount antenna, it has a really good range. It actually has better range than my computer, laptop, and laptop Wi-Fi. We also have a Shield version. Which has a SD card, and I wrote like a little example code that like wgets like a file from the internet and saves it. Not really like, you couldn't like turn this into a BitTorrent client, like not a good idea as a use for an Arduino, but if you want to like send and receive files, like, you know, I want to receive a bitmap and then display it.
Yeah, we're calling this like our Internet of Things boards because this is a lot of things that people want to do. They want to get sensor stuff, they want it to input in, input out, Wi-Fi, very low cost as well. Yeah,
what I like about this module is it's fairly low cost. It's easy to get. The interface is SPI, which means it's easy to use with any microcontroller. It supports 802.11b and G, which is pretty much all you need. Everything supports B and G. You can use WEP, WPA, all those good things. It has a smart config app. So instead of having to type in the SSID and password, you can use the smart configuration capabilities where you use an iPhone or an Android or even a computer, and you can use like the MDNS setup, and you can tell it like, you have, there's a name and password on it, but like if you know that name and password, you can say, log into it and give it the SSID.
So you don't need to do all the weird provisioning and hard stuff that normally is the worst part.
Like you can take it elsewhere. Like let's say you're using it at home, but then you want to take it at work and you don't want to re-upload the firmware. You don't have to. You just connect to it with your phone or computer and tell it what the new SSID and password is for your network. And then I have an all-in-one type thing, which I thought was kind of cute. It just has sort of like an Arduino chip and USB, and also this Wi-Fi, and then the antenna at the end. So you could do like, you know, little project, and the pins are broken out, so you could do little sensor projects fairly easily. And I think there's a little prototype area on the Wi-Fi version.
And we've seen a lot of hardware that's out there that some folks have made breakout boards, but there hasn't been any functional software to get it to work yet. So you've been working on this really hard for months and months and months and months and months.
Yeah, this is actually K-Town did a huge amount of work getting this working on ARM, and also getting it working on Arduino. And then like I came in and kind of, there was a lot of issues with porting it because it works specifically with like the, you know, the Stellaris compiler, but there's actually a lot of compiler level differences that make it so it was not compatible with AVR. Even though it seemed like it was compatible, actually was not functioning correctly. There's a lot of porting to be done. And even though there was an example library for the MSG430, adapting it for the AVR actually is non-trivial.
Okay, so it's coming out soon. Boards are in hand. We just wanted to give you guys a preview. A lot of people asked us about this, so we're like, oh, we'll just put it on Ask an Engineer. So that's what we're talking about right now. Okay, we're going to do a little bit of speed round of questions. We're going to do our best, and then a trivia question.
Little hamburgers.
And then we'll do sorry, not trivia question. It's answer your question time.
Sorry.
All right. Okay.
We will have a trivia question later.
Yeah, hit your questions as fast as you can about electronics and engineering for Lady Ada.
Yeah.
And
LED walls. I know a lot about LED walls.
Yeah, and we'll do questions for a couple of minutes. If you can afford the pins, is there a benefit of using 50 megabits parallel versus 50 megabits SPI? Is that
use whatever you can.
Use whatever you can?
Yeah.
Okay.
I don't know. If you're doing 50 megabits.
If you can afford the pins, is there a benefit of using 50 megabits parallel versus 50 megabits SPI?
If you're doing 50 megabits, there's probably reasons for whatever you're, I mean, it's very specific to whatever you're using.
Is the E-tape liquid level sensor food safe?
I believe it is, but you should contact the manufacturer. We don't make it. They'll probably have notes about whether it's food safe or not.
Okay. How did you connect the panels to the receiver board?
There's little IDC cables that you can connect. You can check the tutorial for like close-up shots, but it's basically an IDC cable. It's a low-cost cable.
This one I'll take. If you have a business collaboration idea with Adafruit, how would you want to contact Lady at Adafruit for these? You can email support@adafruit.com, but we're really, really booked up on all of our projects, so most of the time we have to say, thanks for considering us, we really appreciate it. We have a year's worth of new products that we want to get out
Yeah.
in a few months. We're finally in this new space. We have a fantastic pick and place. We really, really want to get the products that we've been sitting on out the door. Next up. As an electronics major, I'm taking a class on PIC microcontrollers in the fall. Lady, have you ever worked with them? If you have, can you tell me about them?
Yeah, I've worked with PIC microcontrollers. They are ubiquitous. They're inexpensive. They're very easy. You do have to pay for the compiler if you want to use most of the example code out there, which kind of sucks, which is why I don't use it as much anymore, because the compiler, the most popular compiler isn't free. The CCS compiler isn't free. But yeah, every microcontroller is basically the same. So if you learn PIC, you can use anything.
Okay, we're going to do some speed rounds and then trivia question, then we're out. Ready?
PIC assembly kind of sucks, though.
Okay, can I hack a med solar panel jack to connect it to a DC motor to make a solar spin art setup for teaching kids?
Yeah, you could, but
Okay.
it would only work in the sun.
Okay, what's the best way to drive a 32 by 32 pixel art display to display animated GIF style sprites?
You could probably use a Mega in our library. I don't think we have example code for it. You need to be able to buffer the entire display. But yeah, check out the library and try it with the Mega and just play around with it.
Okay. Trivia question time. Whew. All right. Thank you, everyone.
Okay.
Trivia question. Ding, 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 ding. What are the rules, Lady Ada?
Rules are if you've won something fabulous and wonderful from our Ask Engineer trivia question, you can't enter again, only one win per lifetime. If you don't win, don't call us on the phone and complain about it. We're really busy. And the winner gets a PWM driver board? PWM board?
Yeah, the little PWM
You get
driver
one
board.
of our 12-channel 16-bit PWM driver boards.
Yeah.
Handy for all your PWMing needs.
Okay, here is the trivia question. In 1968 of this week, Intel was born. The trivia question is, what was the name they were considering but decided not to use because it sounded like not such a good idea or thing? And they were going to call their company, Intel came from Integrated Electronics, or Intel for short. But right before that, with the founders, they decided they were going to call it. They were going to call it something else, but then they backed out. So if you make a quick trip to the Wikipedia page, you could scroll down. And,
Quick to the Wikipedia.
And you could post in the chat. It's a couple of words, and it is kind of a funny name that Intel could have been.
I'm glad they went with Intel. Intel's a good name.
So let's see. The super awesome computer chip company? No. Gerald Lamerax. More Noise. So
More
it was
Noise.
named after people of the company, but the reason why they didn't go with More Noise because it sounded like more noise.
I know.
So can you
That is
imagine?
pretty funny.
You know, boom, 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 more noise. So that's why they didn't do it. All right. So,
Probably wise.
as also someone has mentioned today, it was Apollo 11 landing. I think Buzz Aldrin tweeted about that today.
Yeah. That's cool.
There was a photo taken on the moon. And that's it. That's our show tonight.
Yeah.
Okay. We're gonna
I'm putting away my video glasses.
Yeah, we're gonna get out of here. Thank you, everybody. Thank you, everyone in the show and tell. Thank you, everyone who was in the chat. It was a great show. Cool stuff. Thank you, our staff folks who showed up tonight. We had Becky and George and Phil B. Thanks, everybody in the forums and on the Adafruit community and all of our customers. We have a lot of cool stuff. We wanted to show you a really neat preview this week.
Check out the video and stuff for the LED wall tutorial.
Yeah.
So you can see it in all its glory.
Real quick, here is a little picture of MOSFET. I didn't have time to do, I have a little video of him. Maybe I'll show it next week of him meowing at birds. But here's
He
a little
loves
picture
birds.
of a cat. And
I mean, he
here
loves to eat birds.
is your moment of Zener.
I can feel the band gap.